Okay, class 11. This is a physics teacher, Mr. D. Pradhan. So this is my first video lesson with you all, which I would like to start by showing you the marks distribution. Okay, you must have seen the very same thing for your chemistry and bio, all right? Because like in your chemistry and bio, we have 70 marks allotted for your theory. Okay, you have to do a project which will carry 10 marks. You have to maintain a lab notebook, of course, which will carry 5 marks, and the experiments or the practical that you do will carry 15 marks. Okay, same as in your chemistry and bio. Okay, I also have requested your class teacher to send you an image of the marks distribution for your theory paper. Okay, so you check that marks distribution also for your theory paper. All right, so today's video, in this video I would like to discuss something that you already know actually, or you ought to know. Okay, it's the main heading is units and measurement. Okay, and in here we start with something called physical quantity. All right, but before we proceed forward, okay, make sure you get a pen and a notebook ready so that you can jot down everything that we've written and anything that we are going to discuss in the video. Okay, so let's start. So I believe you already know physical quantity, okay, are things that can be measured. Any quantity or anything that can be measured is called a physical quantity. Okay, this you all learn in class 6 itself. Example: mass, length, time, temperature, speed, velocity, acceleration, momentum, force, work, pressure, area, volume, density, resistance, electric current, okay, potential, something called surface tension, elasticity, which you'll come to know later. Okay, all these are examples of physical quantities. Okay, then physical quantities can be of two kinds: scalars and vectors. Okay, now scalars are physical quantities which only have magnitude but no direction. Okay, I haven't given the examples for scalars so that you can write the example yourself. Also for vectors, physical quantities having both magnitude and direction are vectors. Okay, you need to write the examples for vectors. And by the way, there's a whole chapter which is dedicated to vectors. Okay, we are going to discuss that, a very, very important chapter, okay, wholly dedicated to vectors. Okay, so we are going to discuss that in the classes to follow. Then after, okay, then physical quantities can also be, some physical quantities are called fundamental quantities, okay, and some are called derived quantities. Now what are fundamental quantities? Let us look at that first. The fundamental quantities are physical quantities that cannot be expressed in terms of any other physical quantity or any other physical quantities. Okay, for example, mass. Mass cannot be expressed in terms of any other physical quantity. Okay, mass, length, time, these three actually are the most basic physical quantities. Okay, mass, length, time are the most fundamental physical quantities. So mass, length, time, there are others also which have been later added, like temperature, you have electric current. Okay, you have what is it called, intensity of light also, which is measured in candela. Okay, these are all fundamental quantities. Okay, so mass, length, time, temperature, electric current, okay, are fundamental quantities. These things cannot be expressed in terms of any other quantity. Temperature cannot be expressed in terms of any other quantity, remember. Okay, now units of fundamental quantities are called fundamental units. Okay, units, all physical quantities have units. Okay, they need units to be measured. All right, so units of fundamental quantities are called fundamental units. Like for example, meter is the unit of length, kilogram is the unit of mass, seconds unit of time, Kelvin units of temperature, ampere denoted by a capital A, okay, unit of current, of course. Then after we have derived quantities, physical quantities that can be expressed or are dependent on other physical or fundamental quantities. Now physical quantities which are dependent on other physical quantities, like for example, let me show you over here. Like for example, here, speed we know is distance upon time. All right, so speed is basically dependent on distance and time. Distance and time meaning distance basically is length, so speed is dependent on length and time. So speed can be expressed as length over time, so therefore speed is a derived quantity. Likewise, velocity, which is displacement upon time. Okay, now displacement also basically is length, so this is also length upon time, so that is why velocity is a derived quantity. Likewise, you have acceleration, velocity upon time. Okay, which can be rewritten as displacement upon time squared, because velocity itself is displacement upon time. Likewise, you have momentum, mass into velocity, which is mass into displacement upon time, because velocity is displacement upon time. Likewise, force, which is mass into acceleration, mass into velocity upon time, because acceleration is velocity upon time, okay, from here. All right, which can be rewritten as mass into displacement upon time squared. Likewise, work, force into displacement, which can be written as mass into acceleration into displacement, which this acceleration can further be expressed as displacement upon time squared. All right, okay, so these are the most basic fundamental quantities: mass, length, time, temperature, electric current, okay, like I said, intensity of light. Okay, these are fundamental quantities. Every other physical quantity that you come across, like I've mentioned over here, okay, every other physical quantity that you come across are derived quantities. Understand that clearly. Okay, and of course the units of derived quantities are called derived units. Units of derived quantities are called derived units. Like for example, meter per second. This is the unit of speed and velocity. Meter per second squared, unit of acceleration. Kilogram meter per second squared, okay, which is also called Newton, okay, which is the unit of force. This is kilogram meter squared per second squared, okay, this is the unit of work or that of energy, which is also called joule. Then this is ampere second. Ampere second is also called coulomb, okay. Coulomb, of course, is the unit of charge. So ampere second is the unit of charge. We know, you must have learned in class 10 itself, okay, current is rate of flow of charge divided by time. So therefore we can write charge is current into time. So therefore the unit of charge will be ampere second, which is also called coulomb. Remember, charge is not a fundamental quantity, okay, current is the fundamental quantity. That is why we write ampere second or coulomb, okay. Ampere second is the derived unit for charge. All right, so I think this much will do for the first video, okay. I'll make another video. In the next video we are going to discuss something very, very important, okay. This is called dimension and dimensional formula. All right, in this video, the things that I've written, okay, the things that we discussed just now: physical quantities, scalars, vectors, fundamental quantities, derived quantities, and of course derived units, fundamental units, okay. No one is going to ask you a question, what is a derived unit, what is a fundamental quantity? These kind of questions you're not going to get, of course. All right, but you need to have basic idea about all of these things: what physical quantities are, what are scalars, what are vectors, okay, what fundamental quantities, what derived quantities are. Okay, you won't get a question as such in the exam, okay, or in the competitive exams, from here. All right, but of course the next video, that the topic on which I'll make the next video, the second video, which is dimension and dimensional formula, this is important from the examination point of view. Okay, so stay safe and take care, class 11. Sorry, thank you.